Hello everyone, today we're going to talk about the real zeros of polynomials, section 3.3 in our book. So the first example wants us to find all the rational zeros of this polynomial. So in order to do that, we need to find all of the factors of our term p, or our constant, and we're going to divide those by all the possible factors of our leading coefficient, and we call that q. So p factors of the constant, and the constant is always just the number that doesn't have a variable next to it, right? It won't change, it's not variable. And then q, leading coefficient. Okay, so then if we think about it, okay, I have my p is 18, right? And the factors of 18 are 1, 3, let's not skip over 2, 1, 2, 3, 6, 9, and 18. And in this case, my q is pretty easy because it's just 1, so my factors is just 1 in itself. So now I need to take, and I need to find all the possible combinations of p divided by q. So p divided by q would give us all these possible combinations. I take the first term of my p divided by the first term of my q. And I can also get the plus or minus of this p divided by q. So I get both the plus and minus when I take and divide those factors. Then I'm going to take all these factors and divide it by the first term of my q, the first factor of my q. So we can all see that that's just basically going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Now and we can see that these are all divided by 1. If my q were something other than 1, now I'd have to take and divide all those factors by the other factor of q. And we'll see an example of that in a second. So now my first step is to substitute the possible zeros into my original equation and see if we can find one of these zeros that sets my equation equal to 0. So I'm going to try p of 1. Or I should say, f of 1. Right, our original equation here. And now I'm just going to plug a 1 in wherever I see an x. So f of 1 is going to be equal to 1 cubed. Remember, whenever I plug it in, I put it in parentheses. Okay, and when I solve that, that gives me negative 16. 1, when I substitute 1 in for x, does not give me 0. So 1 is not a 0 of my function. So I'm going to try the next one. I'm going to try negative 1. Right, so I tried positive 1 because 1 over 1 is 1. That's the first, the first number to check. My p divided by q is 1. So the next number I'm going to check is negative 1. When I solve that, that gives me negative 12. So again, negative 1 is not a 0 of my function. So I'm going to keep on plugging in numbers till I find a value that gives me a 0 for my function. So when I plug a 2 in, and when I plug the 2 in, right, I get 2 from the fact that I get the plus or minus 2 divided by 1. So I just started with the positive 2 first. When I plug the 2 in, I actually got a 0. That's great. So now that I know what one of my zeros is, I take and divide synthetically my function by the 0, 2. So I'm going to really since 2 is a 0, that really means the factor x minus 2 is a factor of my function f of x. Right? So what I really need to do now is I need to take my function, which was x cubed plus 4x squared minus 3x minus 18. I need to take that function and divide it by that factor. Okay, and we're going to use synthetic division. That's really all we're worried about in this chapter is synthetic division. So we've covered synthetic division in the last section. So now we're just going to take this function and synthetically divide it by 2. So if I set up my synthetic division, remember that even though this 0 is x minus 2, the 0 of this denominator is 2, right? 2 would make it 0. So that's why we synthetically divide by 2. Then I put the coefficients down for each term in my function, and we should be familiar with synthetic division. So I carry my 1 down and synthetically divide. Which leaves me with x squared plus 6x plus 9. So what we really just did was we took our original function and saw that when we divide by a 0, right, divide by a factor that we know is, divide by what we know is a factor of our function, we're left with now these two terms. I want to work it all the way down to where I just have linear terms, right? This is a linear term. Okay, so I'm going to have to factor this quadratic, which is convenient for us. Once we get to a quadratic, it should be easy enough to find the 2 remaining factors, because we can just factor this quadratic nice and easy and see that this quadratic factors, well, we know we're going to get next, factors of 9 that add up to 6 are 3. Okay, so we see that the factors of our original function are x minus 2, x plus 3, and x plus 3. So those are the factors. They wanted us to find the zeros or the roots. So we already know that 2 is a 0, right? Because if I set this term equal to 0, solve for x, I'm going to get 2. And so these two terms give us negative 3 for a 0. So that means our zeros are 2 and negative 3 with what we call a multiplicity. So our zeros are 2 and negative 3 with multiplicity 2. What that means is this negative 3 is a double root. Okay? So as far as we're concerned, we've worked from our original function and we found the zeros of our original function. So now just to show you graphically what that would look like, right? We know that our 0, one of our zeros is 2. Makes sense, we cross the x-axis at 2. We also know that the other zeros, right, because we have to have 3 zeros if we have a third degree, right? We have to have 3 zeros. So we know the other 2 zeros are at negative 3. And what you can see here is our graph comes up and just touches the point negative 3, 0. This is what a multiplicity 2 looks like. Right? When we have multiplicity 1, right, just a single 0, it's going to cross the x-axis. But when we have a multiplicity 2, it's going to come up and just touch the x-axis and then turn back down. So that's what's happening here when we have a multiplicity 2. Let's try another example. So now we have a 4th degree polynomial. So we're going to have to find 4 zeros. Again, we're going to start out with our p over q. And again, p being the factors of our constant and q being the factors of our leading coefficient. So the factors of 4, 1, 2, and 4. The factors of q, 1, and 2. So now if I want to find my p over q, that's going to give me plus or minus 1 over 1. Plus or minus 2 over 1. Plus or minus 4 over 1. So that's all of the factors of my p divided by the first factor of my q. Then remember, I have to take all these factors and divide it by the second factor of my q as well. So that gives me plus or minus 1 divided by 2, plus or minus 2 divided by 2, and plus or minus 4 divided by 2. So now those are all the possible zeros this function can have. So, just like the last example, I'm going to go ahead and start plugging in my zeros and seeing if I can find a zero that when I evaluate at that zero, my function is 0. So when I evaluate that number, I get 0 value for my function. Okay, so the first one I'm going to try is 1/2. Okay, so I'm going to do f of 1/2. Okay, I've done a little thinking ahead to see which ones might work, and 1/2 looks like it might work. So I'm going to start there. Nothing says I have to start here. I'm going to start at positive 1/2. When I plug a positive 1/2 in, I get 2 times 1/2 to the 4th minus 7 times 1/2 cubed plus 3 times 1/2 squared plus 8 times 1/2 minus 4. So let me simplify these just a little bit just to give us what the decimal forms of these would look like. So 0.15 minus 0.875 plus 0.75 plus 4 minus 4. Okay, and when I evaluate that, when I add those all up, when I combine all of those, I actually do get 0. So 1/2 is a 0 of this function. Once I find a 0, I go ahead and synthetically divide by that 0. Okay, so I'm going to synthetically divide by 1/2. My original function had the coefficients 2, -7, 3, 8, and -4. So now I just synthetically divide, which we all know how to do. All right, and that leaves us with this polynomial remaining. Right, I know it's a polynomial, not a quadratic, right? Polynomial meaning more than 2 degrees, because I have 4 terms here. So this being my constant, my x term, my x squared term, my x cubed term. So that leaves me with 2x cubed minus 6x squared plus 8. Right, I don't have an x term because it had a 0 in that place. So now again, I got to go ahead and plug in numbers, the original zeros. You don't have to go ahead and find new zeros for this polynomial. You're still using your original zeros, okay? And so basically what we just did was we found that x minus 1/2 is a factor of my original function. And when I synthetically divided that x minus 1/2 out, when I pull it out, I'm left with this polynomial. I need to, again, find a 0, synthetically divide, so I can get down to a quadratic. And then from a quadratic, we can real easily find those zeros. So I'm going to go ahead and plug in 1. So now I guess I should call this a different function. Let's call this one g. So let's call like this function g, only because it's not the original f. So now I plug a 1 in wherever I see an x here. 2 times 1 cubed minus 6 times 1 squared plus 8. Well, when I simplify that, that gave me 4. Now what I'm looking for 0. So let's try -1. 2 times -1 cubed minus 6 times -1 squared plus 8. Well, now when I simplify that, I get a -6, a -2, a +8. I see that -1 is another 0 of my polynomial, of my original function. So I synthetically divide. I synthetically divide my g function, right? After I had divided out the x minus 1/2, I'm going to use this polynomial now. So I write my coefficients 2, -6. Don't forget to put a 0 in for your x term, right? That 0 is still there. Even though we didn't have an x term in our polynomial, you do have to account for it in your synthetic division. Give us a little more space. Okay, so we do synthetic division. And we see that, in fact, -1 was a 0 of my polynomial. So now now I'm left with a quadratic. Now I should be able to factor that. Okay, so I get 2x, x. I know that's going to be the case. I have to get -8 in the middle. I know they're both going to be negative terms because I have a plus here. And so that's going to give me -4. That's going to give me -4. Combined is going to be a -8 in the middle. So my zeros here, if I set 2x minus 4 equal to 0, I get 2x equals 4, so x equals 2. And again, this x equals 2. So my zeros were 1/2. 1/2 was the first 0 I found, right? When I plugged 1/2 in, I found that my function equals 0. So after I synthetically divided, I proved 1/2 was a 0 of my function, and it left me with this remaining polynomial. Okay, so 1/2 was my first 0. Then I had to go ahead and plug in my p over q's again to this new polynomial, right, to see if I could find another 0. And I found that the second 0 was -1. After I synthetically divided by -1, I proved -1 was in fact a 0, and that left me with this quadratic. Now that I have this quadratic, I factor it out into the two terms, find those two zeros, and see that I have the zeros 1/2, -1, and 2, multiplicity 2. Okay, so again, I have another root with a multiplicity 2. Okay, and that makes sense. I have 4 roots. I have 1/2, I have -1, and I have 2 twice. So I have 4 zeros. That makes sense because I had a 4th degree polynomial. So now if we just look at the graph this polynomial gives us, we can easily see, yep, -1, -1. I have a 0 or a root at -1. I have a 0 or a root at 1/2. And then again, you can see at 2, I have multiplicity 2, and it's coming down and just touching the x-axis, bouncing back up. It doesn't actually cross the x-axis there. So we can prove that these zeros we found are in fact zeros of the given polynomial. Okay, I have one more example for you. If you want to go ahead and try and see if you can find the zeros on your own, I'll pause the video right now, and on the next slide I have it all worked out for you, and I'll explain it real quick. So if you want to try this on your own, pause it. If not, if you think you still need another example, I'm going to go ahead and work through another example, but a little bit quicker. So here I have the answer to finding the zeros of this polynomial. Again, I started with my p over q, and I have all of my possible zeros, right? So this, my p has only factors 1 and 5, so I divided them by the first factor of my leading coefficient, 1. So I have either 1 over 1 or 5 over 1. And then I have 1 over 5 and 5 over 5. So I have just these 4 possible zeros, but again, there's really 8 of them because I could have the positive or the negative version of that 0. The first one I tried was 1. Right? So I plugged 1 into my function, evaluated, I did not get 0. Okay, so I tried negative 1. Negative 1, when I plug negative 1 into my function, I see that I do in fact get 0. Great, so negative 1 is one of my zeros of this 3rd degree polynomial. Okay, after I find my 0, I synthetically divide. That leaves me with a quadratic. Then I can factor my quadratic. And I factor my quadratic into 5x minus 1 and x plus 5. That gives me the zeros positive 1/5 and negative 5. So I know I have 3 zeros, or 3 roots. They mean the same thing. Negative 1, 1/5, and negative 5. And again, we can check it on the graph of our original function. Negative 5 is a 0. It's where it crosses the x-axis. Negative 1 is a 0. It's where it crosses the x-axis. And then it crosses the x-axis. It may be hard to see, but at 0.2, which is the same as 1/5, which we already checked to show was an actual 0. So if you want to go ahead and attempt the example problems that accompany this on the PowerPoint, we'll go over when we start class tomorrow.